Hey, how are we doing, everyone? What we're going to look at today is we're going to look at taking two coordinates or 2 points, and we're going to find the slope from them. Or very simply, the way that we call it a lot of times is slope from 2 points. So how do we find that? So first thing we have to do with these two coordinates, we know that every coordinate, and especially if there are two values in this coordinate, they only hold an x and a y value. I can think of that in many ways. I can think of that in a table or a t-chart. I can think of that as a graph where x is horizontal and y is the vertical axis. Okay? And I can also think about it in coordinates. So the first thing we must do with all of these coordinates is label our x and our y values. So here's how we do that. I come to my first point, which is 9, 1, and I label as x and y. I put those x and y's above them. And same thing with 16 and 3, x and y. I must label them, and x comes first in our coordinates. It always comes first in our coordinates. Now, we know slope is going to help us when we actually write in slope-intercept form, which is y equals mx plus b. And we're only going to be focusing on the m part of this, the slope part of it. There's a very long-winded, or not long-winded, but there's another way to actually take two coordinates and find the equation of a line. We're not going to do that just yet. We're just going to find the slope from these two coordinates. So, here's what we're doing. First, excuse me, I'm bringing that back. Now, once we have this, we've already talked about slope as a manner of our change in our y values over the change in our x values. And between these 2 points, we're going to use those coordinates to find how are we changing in our y value, how are we changing in our x value. And here's how we do that. Now, I'm going to take a look at my y values because we know slope is also a rise over our run, which we rise only on the y-axis, we run on the x-axis. So, the first y value I see, and I'm going to label, make sure that this is 0.1. This is coordinate 1, which means the second point right here is 0.2. Therefore, I'm going to start with 1. So imagine you're starting with that 1 for that y value, and then you're moving to what other y value? Well, we changed from 1 and went to 3. That's our change in y. Our change in x then, well, if I'm starting at 0.1, the 9 corresponds to 0.1. So therefore, if I was starting at 1, I'm going to start with this 9 here. And I changed in my x value to positive 16. So now it's just a question of how much are we changing by and what direction are we changing? Meaning, are we going up, which would be positive, or are we going down, which would be negative? So let's take a look. From 1 to 3, how did we change? We went up. And by how many? We went up by 2. So that means it's a positive 2. Over, we went from 9 to 16 then, which that's a positive change, and a positive change of 7. So that means, I made a little mistake down here, that our slope then is 2 over 7. So now what I could also do that as, I could also write this if I wanted to, write them in a table to show where I'm getting those changes from. Now that would mean that if I was putting them in a table here, we're starting with 9, 1, and then we're going to 16, 3. And this is a way that we've seen it before, and we're very comfortable with solving for these tables right here. So my change in y, again, went up by 2. My change in x went up by 7. That's all we're doing just in change in y over change in x. And that's how I'm actually thinking about it. Now, if I wanted to, I could actually do this in reverse as well. Meaning I could start with 0.1 as 0.2, so I can make this 2, and this can be 0.1. That would work as well, it's just we're going to be in reverse. So if I reverse this, I would really have, I'd be starting at 3 and moving to 1. But that would also mean that I'm starting at 16 and moving to 9. Well, what happens there? From that case, 3 to 1, that's a negative change because I'm going down, so that's a negative 2. And then 16 to 9, I went down again by 7. Well, I have a negative 2 over negative 7. Now, with slope, we want to reduce this fraction or simplify this fraction. And we know it is improper to have two negatives in the same fraction, which therefore means a negative divided by a negative is a positive 2/7 again. So you can go in reverse, and that will still get you the same solution. Okay, so here's the next one. Now what you're going to do, again, you're going to label x and y. So we're going to label as x and y in both coordinates. And then again, we're going to use that formula change in y over change in x. Excuse me, change in y over change in x. Okay? And now what it looks like, we're going to do it again with this time. We're going to start at, if I'm going to say that this is 0.1 and this is 0.2, it means I'm going to start with the y value of 6 and I move to 4, that second y value. And then my change in x from there, I'm starting with -2 because that's in 0.1, and I'm moving to -5. And in this case, I'm going to figure out how I'm changing. 6 to 4, I went down 2, so therefore that's a -2. And then -2 to -5, don't be confused, I actually went down 3 again because I'm getting further negative. That's a key part that we want to make sure we look at. When there are two negatives, are you getting closer to 0 or are you getting further away? In this case, -2 is closer to 0 than the -5, so I went down. Now what do we notice again? I have two negatives here, which therefore means our slope is going to be a positive slope of 2/3. Now, finishing up, there is an additional way that we could solve for slope, and that's going to be a different formula, but essentially it's the same thing. All right. Now, the more techie way to do it is slope formula, where you actually have, this is the official one, y2 minus y1 over x2 minus x1. And what that all means is the second value, the second y value, so y in coordinate 2 and x in coordinate 2, you subtract to find the difference or that change again. Okay? This is the same thing, it's just we're going to be labeling it a little bit differently. Instead of actually looking as in change in y over change in x, we're looking at it as just how are you changing. Here, it's always subtraction, so we have to be a little careful with our signs. So what I typically do is I label my points, but I label them differently, as point 1 is always x1, y1. The second point I see is always x2, y2. Okay? So now all I'm going to do is substitute, which makes it pretty simple. So for y2, I see that 4 is my y2 value. So that means I'm going to be taking 4, and I'm subtracting, where's y1? Well, I already labeled that as 6, so I have a 4 minus 6. For the x2 right here is -5, so I'm going to plot that in. Just going to substitute it in. Minus, and here's where you have to be very careful, especially because this is a -2. I need to write this in as minus a -2. Now, I use parentheses there because we know what's going to happen between these double negatives down here. All right? We know these double negatives are actually going to make a positive. So that's where you have to be a little bit careful with this method. Very effective, but again, be careful with this. Okay? Last step then is actually to subtract. So therefore, 4 minus 6 we know is -2. And then -5 plus 2, different signs I subtract in there, so that means that's a -3 as well. And realistically here, I said last step last time, but realistically, this right here, negative over negative, we know is actually a positive 2/3 again. So two different methods to actually solve for slope between two coordinates. Okay? So what you're going to do now, you're going to go through and you are going to complete the form that I gave you on Google Classroom. All right, do the best you can with those. And if you have any problems, please let me know.